Okay guys, the 3 Atlas thing keeps hitting us with deeper and deeper mysteries. It just reached its closest point towards Earth on December 19th, and guys, the thing with this object is that we are discovering more anomalies, not the opposite. We cannot cross some off the list. We simply can't. We just found another one. We just found anomaly number 16, and I really have to say that something entirely new just dropped about 3 Atlas. And really guys, this is not a small detail. It is about the spin axis of the object. We have talked about this in my last video, but we really have to talk about this again because there is something, how can I say this? You need to listen closely, okay? It is about the spin axis of the object, right? Meaning exactly how the object is pointing while it rotates. This is another weird thing that would be highly unlikely if this is just a normal comet. This is how significant that is. So let me walk you through this carefully because the idea sounds technical, but it is actually quite simple once you picture it in your mind. I am going to show you this graph here. It shows the direction of the anti-tail jet over time. Anti-tail here means a narrow feature that appears to point towards the sun in the image. Now the key measurement is the position angle. It is just a fancy way of saying what direction the line is pointing in the sky. It is like using a compass but used in the sky. So they measured that anti-tail direction at a projected distance of 6,000 kilometers from the brightest part of 3 Atlas. That is roughly 3,700 miles. And then they phased the measurements. That means they folded the data into a repeating cycle, like turning many days of observations into one repeating clock. So they found this repeating wobble that we talked about with a period of 7.74 hours. That means every 7.7 hours, this thing rotates a full rotation around its own axis. The red horizontal line that you see in the image is the average direction of the jet angles. And that average direction gives you the sky projected orientation of the rotation axis. So what does this new paper imply? It implies something very specific. It implies the base of the jets is offset by less than 8 degrees from the poles of the object. And that is odd and huge because that means the jet is coming from near the top or the bottom of interstellar object 3 Atlas, off the spinning, rotating object close to the spin pole like with our Earth. And as the object rotates, the jet precesses. Precessing means in that case, guys, it does not point perfectly fixed. It makes a little cone motion like a spinning top that wobbles while it spins. That is why we call it wobbling, right? Imagine just this, a spinning object, a jet near the pole, and the jet direction wobbles in a small cone. And the key is that the wobble is small, less than 8 degrees. So here's the object. There is the jet. And this is the wobbling, right? The big inference involves what we can call the steady day side, steady night side. What does that mean? That is the logical jump from this geometry that we just talked about. So, that far from the sun, 3 Atlas is now getting away from the sun again, right? It is approaching Earth and has a still steady day side and a steady night side. What does that mean? It means one hemisphere keeps facing the sun most of the time and the other hemisphere stays mostly dark. That can happen if the spin axis is lined up with the sun's direction. So instead of everywhere getting sunlight during a rotation, it is more like one side is mostly the sun side and the other side is mostly the dark side. And normally these roles would switch at perihelion in this geometry. So why is this another anomaly? Harvard professor Avi Loeb says it is the 14th anomaly. We have the 16th because we have anomalies from other scientists. So let's say if the jet is just natural cometary behavior, like a pocket of ice that releases gas when sunlight hits it, then this geometry becomes a new anomaly. Why? Because the spin axis being aligned with the sun direction that closely, that is unlikely. The alignment is within only 8 degrees. And this already happened when 3 Atlas was still far from the sun, before perihelion, at a heliocentric distance larger than 5 AU. That means Earth's sun distance, 1 AU, is about 93 million miles. So 5 AU is 465 million miles. So that means even if 3 Atlas was way out there, the spin axis was lined up with the sun direction as if, okay, it specifically wants that direction. Avi Loeb has given this a statistical probability, calculating how likely this is that a natural comet does this. The chance of this happening randomly is 0.5%. That is 1 in 200. And why would misalignment have looked different? That is what we also need to look at. What would happen if the alignment was not special? If the rotation axis was not lined up, the anti-tail jet would be at a much bigger angle relative to the spin axis, but it is almost aligned. That is the strange thing. It is not larger. And also, if the alignment was worse, the jet might show gaps, but it doesn't show gaps. Why would it show gaps? Well, logically, because the source region would rotate into night, lose the sunlight, and then shut off, then rotate back into day, and then turn on again. If you have a spacecraft, you want continuous jets, right? Especially since you change your direction during perihelion towards Jupiter, which it did. It is another anomaly, guys. It is so interesting, right? I am not saying it is one or the other. You be the judge of that, and hopefully the data that we will receive soon will give us more clarity. So basically, the fact that this alignment stays narrow and consistent suggests a special geometry. Let's call it special geometry, right? We don't want to say someone built this. Look at this multi-panel image with arrows and lines here everywhere. What are we seeing here? These are images of interstellar object 3 Atlas, right? The thin purple lines show the measured anti-tail position angle at 6,000 kilometers from the brightness peak, like 3,700 miles. There is this dotted red circle that is marking the distance scale. And each panel that you see includes the date, the UTC start and end times, and how many exposures were stacked. So the arrows that you see, the red arrow is the projected velocity direction. A yellow arrow is the anti-solar direction, meaning directly away from the sun. The orange lines show the derived projected rotation axis direction. Yellow lines trace the regular tail direction. The brightness contours are drawn as levels from the 20th to the 95th percentile of pixel intensity. So the anti-tail is the narrow linear dark feature extending roughly northwest in the direction of the sun. Okay, let's get back to what happened before perihelion. The earlier alignment applies before perihelion, but after perihelion, there is a new revelation. After perihelion, that was on October 29th. New images from Hubble and other ground-based telescopes still show the prominent anti-tail jet towards the sun, and we still see it in the latest images from December 15th and 16th. It is still there. And here is the key complication, as you might say. After perihelion, the object is receding from the sun, right? And the same side that faces the sun is not the same side as before, which makes sense, right? So when it was approaching in July and August, the side that is now facing the sun used to be the night side. So the jet base that launched the anti-tail in July would now be on the night side, turned off. So if you insist that this is a natural comet with ice pockets, then you also need a new ice pocket near the opposite side of the pole. Not just that, oh, we had it on this side, oh, now you have it on the other side too, to create a new sunward anti-tail after perihelion. And you also need the old active region to shut down. So that is really another, let's be careful, anomalous feature. Very, very odd, right? We can call this the second power. What is the second power probability? Yeah, listen guys, now comes the math punchline. Harvard professor Avi Loeb says the new anti-tail is collimated within 8 degrees out to 500,000 kilometers in the latest image from December 15th. We talked about it. It is long. It is huge. So 500,000 kilometers, guys. It is about 310,000 miles. That is bigger than the Earth-Moon distance. I have talked about this in my previous videos. So this collimation, as it is called, plus this unusual geometry marks it as this new anomaly, meaning you need 2 separate favorable alignments, and they happened. What a coincidence, right? So one pocket near one pole for the inbound face and another ice pocket near the opposite pole for the outbound face. What a coincidence that you have these jets there. I don't know, guys. Really, each alignment has a probability of 0.05. So the squared probability, if you multiply both, is 0.0025. That is 0.0025%. Basically, that is 1 in 40,000. That is the probability that this happens with a normal natural comet. Of course, let's talk about the spacecraft comments that Avi Loeb makes, and he is heavily criticized by media for that. And I really don't understand it, because if NASA were out to explain these 14 to 16 anomalies, yeah, we would feel better. But they do not mention them at all. They just say it is a normal comet booster. They are not even talking about the anomalies or giving us an explanation. Avi says a technical spacecraft might have a reason to align its gas outflow from thrusters in the direction of the sun, but he also said we do not have high-resolution images of the jet direction near perihelion, unfortunately. So he is not claiming proof. He is saying this geometry would make sense for a spacecraft, but we do not have the decisive imagery. Does someone have it? I don't know, guys. Really, I don't know. But why is this collimation so puzzling that these jets, the jet stays tightly collimated out to 500,000 kilometers, $310,000 mi, and that is really surprising given the solar radiation pressure, the solar wind, especially after perihelion when you expect pushing and broadening, right? It should go in the other direction and not so long and strongly towards the sun. So why? The main questions that arise are, why does this sunward jet stay narrow? Why isn't it broadened or pushed away from the sun by the solar winds? What are the jet speeds and the mass loss rate? This is what we are hoping to get now that we passed December 19th from the spectroscopy, right? A spectroscopy of the jet material will hopefully clarify how the anti-tail is launched, and that maybe will give us another answer. But there is something else. We talked about the rotation every 774 hours. We thought before that it is rotating every 15 to 16 hours. So the 774-hour rotation schedule might imply the real nucleus rotation is double that. So it could be 15.48 hours if there is only one active spot at a time. So this would be consistent with a rotation period derived from brightness variation in July when we said 16 hours. So still these numbers match reasonably well because some of you asked me after my last video, why did this change, right? The radius of the nucleus is still assumed at roughly 2 kilometers, that is 1.24 miles. So with a rotation period of 15.5 hours, the centrifugal acceleration, that would compute the centrifugal acceleration at the surface. So that will be 0.0025 cm where S2, and that is extremely tiny compared to Earth's gravity. That is 1 joule. So that is about 2.6 millionths of the Earth's surface gravity. So the interesting point that Avi Loeb then makes is when we look more at the artificial side, to generate artificial gravity like the Earth by spinning, you would need a rotation period as short as 1.5 minutes. So the current spin of 3 Atlas is not producing meaningful artificial gravity. Summary. So this new paper finds this small periodic wobble in the anti-tail direction, implies the jet source is near the spin pole within 8 degrees, which implies the rotation axis is closely aligned with the sun direction even at a large distance. The random chance is only 0.5%. After perihelion, the anti-tail still appears sunward, implying a second favorable polar ice pocket scenario if it is a comet. That squares the probability to around 0.00025%. So the jet staying narrow out to 500,000 kilometers, staying that narrow to 310,000 miles, raises serious questions about how it stays collimated against the solar forces pushing and wanting to push it in the other direction. Spectroscopy could clarify the mechanism. Hopefully, rotation period estimates are broadly consistent at 15 to 16 hours. The spin is far too slow to generate Earth-like artificial gravity. So, we will have to wait and see, guys. Even after this video, I have even more new stuff. I just don't want to make this one too long. So, subscribe, hype, and like, guys. And if you want to fill me up with coffee, the link is in the description of this video. And check out one of the videos here in the end screen. I also have a playlist for 3 Atlas